So, question number 14 is what is the ball's acceleration at time t equals 1 second? This is based on a ball of mass 2 kilograms is thrown vertically upward from the top of a building. The ball's velocity v is given as a function of time by the equation v of t is equal to r minus st, where r equals 5 meters per second and s equals 10 meters per second squared. The positive direction is upward. So it wants us to figure out what the acceleration is at time t equals 1 second. So if we use our kinematic equation, v is equal, or v final is equal to v naught plus at. That's basically what this v of t function here is. We have v of t is equal to r, which is v naught, 5 meters per second, plus at, and acceleration is going to be negative 10 meters per second squared because that's the acceleration of gravity, due to gravity. So that's the answer to number 14. It's A, negative 10 meters per second squared. But if we write that out, it will make us have minus 10t. So if we then use this function, v of t is equal to 5 minus 10 times t, we can plug in 1 second for t, and we'll get v of 1 is equal to 5 minus 10 times 1. So v of 1 equals 5 minus 10. So v of 1 equals negative 5. So at 1 second, the ball has an acceleration of negative 10 meters per second squared due to gravity, and it additionally is moving at negative 5 meters per second. So the concepts behind this are that the force of gravity acting upon the ball causes it to have a downward acceleration. So when you throw the ball up into the air, it won't really have that much of an x acceleration other than the x acceleration you gave it by throwing it, but it will have a constant downwards acceleration of 10 meters per second squared because of the force of gravity. So as it travels up, it will be traveling up slower and slower as the velocity has a as the velocity has a downward slope, and then until it gets to the point where the velocity equals 0, the ball has then reached the top or the vertex of its parabola, and it will start to travel downwards with the velocity continuing to become more and more negative as the acceleration is negative, making the ball's downward velocity higher and higher in magnitude. What this means is that the ball will continue to fall faster and faster until it reaches the ground. One of the possible answers here is C, which is just 0, and that simply is not possible because for it to not have an acceleration, it would need to either have it would need to have a net force of 0, and that's not the case. the only force acting upon it while it is in the air is the force of gravity pulling it downwards. Answers D and answers B and D are incorrect because we know that the acceleration is 10 due to gravity, and B and D show 5. But we know E is incorrect because the problem specifies that the positive direction in this situation is upwards. So since our acceleration is downwards, that makes our acceleration negative 10